Okay, so now we're going to be talking about 4.2, graphing quadratic functions in intercept form. So there's three forms. You've done standard form, you've done vertex form, and this last form is intercept form, which means when you look at it, you'll be able to see what the intercepts are, the x-intercepts are. This formula is given by y equals a times x minus p times x minus q. And then for us, it's kind of the same formula right here. You're going to need to memorize this. So if you want to put a star by it or highlight it, do something, but make sure that you memorize this formula. So characteristics, the intercepts are p and q, and just like when you had the h for your vertex, you have to switch the signs for p and q. So it's the opposite of p and the opposite of q for this and this. We will always write these as coordinates, so p comma 0 and q comma 0. And the axis of symmetry, which is this line that still divides it in half, is going to be given by x equals p plus q over 2. So we have to do a little bit of work here, but not nearly as much work as we had to do when we did vertex form. And then the same thing with the a still applies. If a is positive, it opens up, and if a is negative, it will open down. So let's see this in action. Graph the function, label the vertex and the axis of symmetry. So looking at this one, I see that a is positive, which means that this one will also open up. So opens up. Should look something like that. And I see my p is negative 1 and my q is 3. Remembering we have to switch the signs for these. So as a coordinate, I have negative 1, 0, and 3, 0. That's 2 of the 5 points that I need. So go ahead and plot those. The next thing I need is my axis of symmetry, and to find that, I'm going to add, so remember from the previous slide, it's p plus q over 2. So it's negative 1 plus 3 over 2, which is 2 over 2. So my axis of symmetry is at 1. So go ahead and draw that right now. And don't forget to label it x equals 1. One way to check yourself, it should be right in between your two intercepts, which ours is absolutely dead smack right in the middle of those. So I need the vertex also. So the same way that we've done before, in order to get the y part of that, I'm going to plug it in. So I'm going to have 1 plus 1 times 1 minus 3. And then we have 2 times negative 2, which gives me negative 4. So my vertex is 1, negative 4. I'm in good shape right now. Oh, I don't know why I just did that. We knew the vertex. No, we didn't. No, I'm just kidding. 1, negative 1, 2, 3, 4. Just had a moment there. And I'm going to label that 1, negative 4. This is a good look for us. We have 3 of the 5 points that we need right now without doing too much work. So we need one more point, and I'm going to pick any x value I want to. I'm probably going to pick 0 because it looks easy and because it's on one side of the vertex. So I'm going to plug in 0 for x, and so y is equal to 0 plus 1 is 1. 0 minus 3 is negative 3. So negative 3 for that one. So 0, negative 1, 2, 3, and then I'm going to reflect it and connect it. There you go. That is graphing in vertex form. Let's try one more of these, because sometimes the vertex doesn't work out to where it's an even number, and I don't want you to freak out if you get that. So this next one is y equals negative 2 times x plus 2 times x minus 3. Looking at this negative, the a is negative for this one, so this will open down. And my p is negative 2. My q is 3. Don't forget we switch our signs. So this as a coordinate is negative 2, 0 and 3, 0. So go ahead and plot those now, negative 2 and 3. And to find my vertex, I'm going to have x equals p plus q over 2. So negative 2 plus 3 over 2, which gives me 1/2. Not afraid of the fraction, so don't you be either, because I'm here. I am here with you. I got you. But go ahead and draw your axis of symmetry. This is probably, if this is difficult, this is as difficult as it gets for these types of problems. So x equals 1/2. So y is equal to negative 2 times 1/2 plus 2. Some of you like the decimal points. I know at least one student that does. And so I think I might just do this one with decimal points just for her. This is 2.5 and this is negative 2.5. You can do this in your calculator or you can trust me. And then when you multiply all that out, you get 12.5 for your y value. So my vertex is 1/2 and then 12.5. I know I keep going back and forth from fractions to decimals, but it's just 0.5, so don't be mad at me. So count all the way up to 12.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, I had to do that out loud. 12.5. So this is 1/2 and 12.5. I just need one more point now. So we did all that. We just need one more point. So I don't know. You can pick 0 or you can pick 1. It doesn't really matter completely to me. I guess I'll do 0 because it looks easy. But no, it's probably going to be really, really close to this. So if you're not good at drawing these so much, pick a point that's a little bit further, like negative 1, and then you'll be okay. But I'm going to do x equals 0. So I get negative 2 times 0 plus 2 is 2, and 0 minus 3 is negative 3. So when I multiply all these out, I get 12. So I'm here and I'm here. It does open down like I had predicted, so my points are looking pretty good to me. I'm going to round off the top here and go ahead and connect the rest of the way down. I know that's not the cutest one, but yeah, love me anyways. That is graphing in vertex form. Now the last things that they ask you to do is to write these quadratic functions in standard form. Standard form, just as a reminder, is y equals a x squared plus bx plus c. That means I don't want parentheses. I want to multiply this all the way out. So a little bit of a flashback for you and also preview because we'll need this a little bit later on. FOIL, if you remember that. Some people do use different methods, but I'm going to use FOIL. If you do something else, go ahead and do it now. You can press pause and then just see if you get the same answer as me. But for those of us that FOIL it, remember it's the first term. So x times x is x squared. Outer, so that's x times 5 plus 5x. Inner, 4 times x, which is 4x. And last, these are the two last terms of that, so that's plus 20. X squared plus 9x plus 20 is equal to y. And that is standard form. Now, number 7 is a little bit different. G of x is the same thing as y, so that's not stressing me out at all. I hope it's not stressing you out as well. But this, I can use a special product. And here's a special product that I'm going to be using for this. In case you don't remember, because it's been a while since you guys have had Algebra 1. A minus b squared is equal to a squared minus 2ab plus b squared. If you hate this, you can go ahead and FOIL this out, but we will have to use this over and over and over again. So if you do hate this, take a step off the haterade and start liking it, because you're going to use it a lot. So for this one, my a is the same thing as x, and the b is 1. So a squared just means x squared minus 2a is x, b is 1, so 2ab, plus b squared, so plus 1 squared. And then you'll simplify. So this is going to be 3 is still there, and then x squared minus 2x plus 1 plus 7. Distributive property, which you all know and love, 3x squared minus 6x plus 3 plus 7. Last thing that I can do is to combine these two terms. This was squared. And so we have 3x squared buzzkill, minus 6x plus 10 is equal to g of x. And that is standard form. Thank you so much for joining me. I hope you enjoyed this video just about as much as I enjoyed making it for you. Have a great day.